Okay, so the next step that we need to dive into in our machine setup is going to be setting up our tools. So setting our tool length offsets. So in order to do that, there's multiple ways to do it on this controller. We're going to demonstrate one way, which is going to be effective for everybody to use, and it's also one of the easiest ways. So the first thing I want to do is come to my controller and go to the menu system and cycle through the menus until I find setup. That's going to be under the functions subheading here, and setup is going to be option 1. So I'll hit option 1 for setup, and then I'm going to start by setting up tools in the machine. So again, I'll hit option 1. Now, I'm going to recommend that you always use the multiple tool option, and the reason being is that when you do that, the controller walks you through a nice setup routine that basically takes you step by step through all the processes that you need to do to touch off and measure your tool length offsets. So we're going to do multiple tools. Even if you only have a single tool to do, you'll do the multiple tool option. That's going to be option 2. Then the controller is going to ask you what tool numbers do you want to set up, and you can put in any range of tools you want. So I can do tools 1 through 10, I can do 10 through 15, whatever the case may be. So for our example today, we're going to do 2 tools. So we'll start with tool number 1, and our ending tool will be tool number 2, and I'll enter that. Okay. Then the next screen is basically asking you, how do you want to make your tool length measurement? We only have one option, and that's to use jog mode. Options 2 and 3, which are indicating for a probe, or if you had a digital touch-off probe, which we currently do not have on this machine. So we'll always be doing option 1, jog to position. So I'll press 1. And now it's going to ask me for a height block size. So basically, this is the machine asking you what size of gauge block or reference block you're going to be using to make your measurements with. In our case, we are going to be always using a 1, 2, 3 block. So this is 1 inch, 2 inches, and 3 inches, all precision ground to very, very tight tolerances, close dimension, so it's square, parallel, all those things. And we're going to use this to essentially touch off our tools. And we typically use the 3-inch side right here. So this is 3 inches, and I'm going to indicate that in the controller just by typing 3. And that gets entered in, and then our final menu is coming right here, and we have a couple pieces of information that we need to enter. Option number 1 is what's the diameter of our tool, so I can go ahead and enter that. The first case, I've got a 3/8" diameter end mill, so 0.375. Hit enter, and then I can go in and do option 2 to locate length. So this is locate length is where I actually will make my measurement on the machine. So I'll press 2, and then I get a little indication or a little message to tell me to go into jog mode, which I will do, and now I can come in and make my measurement. Now, before I actually measure my tool, I actually need to load it into the spindle. So currently there is nothing loaded into the spindle. I'm going to grab my tool in my hand, and just a quick note about safety for our tool holders. This is our Cat 40 tool holder that we've learned how to load in a different video. But I want to make sure when handling this that I'm handling it in the safe zone. So you can see there's this kind of double flange right here on the tool holder, and I want to ensure that when I'm handling any tool holder, I always have my fingers below that double flange. So this is the safe zone. This is safe handling of the tool holder. If I get my fingers up here into this flange zone, then this is a pinch zone. So I'm in danger of potentially pinching my fingers when I load this tool into the spindle if I'm holding like that. So this is a no, and this is a go. This is how we want to do it. Additionally, we have a variety of different holders from different manufacturers, I should say, with our Cat 440 holders. But one thing that you will notice with all of them is that there are two different grooves on the holders. One of the grooves is always slightly deeper than the other. And for our machines, we need to align the deep groove, always the deep groove, to the notch on the spindle that has an X scribed into it. And by doing so, that'll ensure that the deep groove always mates up with the notches in our tool changer, so that the tool changer arm can correctly grab and engage the tool holder and successfully do a tool change. If you load it in the wrong way on some of these holders, this shallow groove is in fact too shallow for the tool changer to actually grab on, so it can drop the tool if you load it in the wrong way. So we want to identify where the deep groove is. We want to look on the spindle for the scribed X, and then we want to line those up and load it. So the way I'm going to load it, I'm going to hold it here in my left hand in the safe zone. I'll come over to the controller. Right here on the second row is a tool in and out button. And what I need to do is push and hold that to allow me to push this up into the spindle. And then when I've got it shoved up, I can release the button and the machine will pull the tool holder up and seat it into the spindle. So here we go. Push that in. Release it, sucks it up to the spindle, and now tool 1 is loaded into the spindle. From here, I can grab my gauge block and then go through the rest of the procedure for measuring my tool length offset. So conceptually, what we're doing here then is essentially trying to record the distance that the machine needs to move from our home position down to some common datum, some common reference that all of our tools will be measured from. Now, if we had a touch probe, maybe mounted over here on the side, or somewhere else, then we could go over and use that as our reference. But since we don't, a very useful and well-established reference is going to be our machine table. And that's because the machine table is always there. You can always get to it. So in the case of where if you're running a program and you happen to break a tool and you need to replace it, I can get to some area on the machine table in order to reset up another tool. So we use the machine table as our datum or as our reference for doing our tool length offset measurements. So what I'm going to do is just basically jog this tool over next to our 1 through 3 block and then go through the measurement routine. Now before I actually do that, let me just quickly describe how we're going to walk through this touch-off procedure. So imagine that my finger is the end of a tool. What I want to do is jog it over, bring it down so that my tool is below the surface of my 1, 2, 3 block, and then just slowly step it up until I get to the point where I can just slide my 1, 2, 3 block underneath the tool. And I'm going to do this starting with a 10,000ths inch increment. So as you can imagine, as I get to the point where I can't slide the block underneath the tool to the point where I can, at that point I'll know that I'll be somewhere between 0 and 10,000ths of an inch above my 1, 2, 3 block. Then I can drop back down again, switch to the next smallest increment, and then repeat that process. And by doing so, what it'll essentially allow me to do is to get within 1/10,000th of an inch, which is again our smallest increment here in jog mode, away from our 3-inch gauge block. So it's a fairly accurate measurement of our tool length. And it's going to be certainly accurate enough for what we're needing to do. Okay, so I'm in jog mode. We'll start by jogging the spindle back in Y. So I'm going to use the keyboard to get it back here in continuous jog function. So I roughly locate it. Now note that I have the 1, 2, 3 block set off to the side from the tool, because now I'm going to bring the tool down in Z, and I don't want to have the gauge block underneath the tool, just to prevent any inadvertent crashing of my cutter into the 1, 2, 3 block. So cutters are expensive. We don't want to smash and ruin those. And of course, 1, 2, 3 blocks are precision tools as well. So we don't want to bring those two things together. All right, so I'm going to come down in Z. At this point, you're just kind of readjusting things until you get it close. So I've changed over to the hand wheel at this point to give me a little bit more control over the jog, because I'm close to my 1, 2, 3 block, and I don't want to inadvertently run into it. Other thing to note, if you have stuff set up on your table at this point, like for instance, we do have a vise set up and a piece of stock set up there in the machine, I need to be aware of what's going on around the head as it comes down, because shorter tools, the head's getting down pretty close to the table, and you've got a potential for crashing into your setup. So be aware, always be aware of what's going on and your clearances around the head as you come down in Z. Okay, another little adjustment here. All right, so this point, I can still slide it underneath, so I need to continue to come down in Z. All right, now I'm at a point where I cannot slide the block underneath the tool. So I'm going to come over here and take advantage of my incremental jog mode, which again is if I just push the button, the jog button one time, I will move one increment, either the positive or negative direction, depending on how I have my controller set. So I cannot slide the block underneath it. I need to move the head up. So I'm going to go positive Z, so plus. Now I'm Z positive and H, so that's 0.1 of an inch per touch of the jog key. So I'll bump the jog key once and then try to slide it underneath. And I'm not able to, so I'll bump the jog key again. And continue that process until you get it where you can slide the 1, 2, 3 block underneath the tool. All right, so there we go. Now I can slide it underneath the tool at the 0.1 of an inch increment. I want to come back down, so again, make sure the gauge block is away from the tool so you won't come down on top of it. I'm going to change direction to negative and then go back down one increment. And so again, I should not be able to slide it at that point. Now change my increment, so I'll do it over here on the increment selector switch this time, and switch it to 1/1000 of an inch, so 10 times smaller, and again start going back up. So positive, and we're still in Z, and then hit the jog button, and try to slide it underneath. There we go. So now I'm 1/1000, somewhere between 0 and 1/1000 inch above the top of my part in Z. And I can do the last increment, so I'll bring it back down again. There we go. And go to my finest increment of 1/10,000th of an inch and repeat that process one final time. There you have it. I only had to hit it one time and I was above the part. So at that point I would say this tool has been touched off and measured, and we can continue on to the next value. One note here, so when I press the manual button, as it's asking me to do right here where it says manual to abort, what really the controller is going to do, it's going to take this value, which is the current position of Z relative to our home position, and it's going to write that to the tool length offset register in the controller, plus or minus an additional 3 inches. So we can expect in the tool length offset Z register to come out at minus 19.6959 for tool number 1 when we go check that. Okay, so I'll push manual. And then it's basically going to want to jump into auto mode to do a tool change. So I'll press start to do load tool 2, and I'll do that. And the machine does the tool change and allows me now to load tool 2. So I'll continue to grab tool 2. In this case is a drill bit. For this one, I'm not going to bother with the tool diameter. I'll just skip that and go right to locate length. So I'll press 2 and then jog. Same thing, identify the deep notch in the holder. Grab it with my left hand in the safe zone. Identify the tab that has the X scribed on it. Push and hold the tool in and out. Push it up in there, release the key, and the machine pulls that up into the spindle. And then we just go through the same process to touch this tool off. So we're going to be jog, we're going to come down in Z, negative. Make sure my increment is larger. Now I want to give myself a little more space. So I can start here. All right, so now I can slide underneath it at 10 thousandths, and I'll drop back down to 1, and then switch my increment level, and then go back up, repeating this time. And this time I'm just using the pulse generator wheel, the manual pulse generator wheel. So the point being, whether or not you use this or the jog key really is user preference. They both will work. You just got to decide which one you want to use. Okay, so at this point, I'm within 1/1000th of an inch of my gauge block. And for a drill bit, that's probably good enough, especially if we're using this drill bit to maybe drill a through hole in our part, then the depth dimension is likely to not matter. Now you have to evaluate that for yourself depending upon the tolerances of your particular project, whether or not you need to continue to the next level of precision for your setup. But let's say in this case that we're doing a through hole, it's programmed to punch through the part quite a bit, so that additional accuracy isn't necessary, so we'll take advantage of not needing to take advantage of that and not waste the time during setup to go to the next level. So we'll press manual and then start, and it will take the head back up to the top. Now, one thing to note, I was loading the tools while going through the setup program into the carousel. That is a very effective and efficient method to do it. I can have all the tools basically staged out on our cart beforehand, go and do my tool setups, and then load them into the tool changer as we go through this. But that is not necessarily the only way you could do it. You could also load the tools in the tool changer directly, going into MDI mode, for instance, and then executing tool changes to get the tools in there. And just to demonstrate that, I'll do that one time by going into MDI mode and walking you through how you can just load tools in MDI mode. So to get to MDI mode again, multiple ways, but the best way is just to keep cycling manual, and I shouldn't say the best way, one way is to keep cycling the manual key until I get there. So I'll push it 1 to exit out of the edit mode, and then 1 more time, and again, drop you back into the manual data input mode, where I can enter G-code directly. G-code for doing a tool change is going to be an M6 followed by the tool number that we want to load. So let's say we'll go ahead and load T3 this time. So M6 T3, I'll hit enter. Now one nuance about the Fadal controller, always on the first code that you enter into the system that tells the machine to move, it's gonna drop into the waiting period and want you to acknowledge that you want to do the motion. After I've done this first mode and hit it start, then it will no longer ask me for this acknowledgement after I type in the code and hit enter. It will execute after I hit enter. So we'll go ahead and execute this tool change by hitting start. And there we go. So now the spindle is free, and I can grab another tool. In this case, I'll grab an edge finder, which we'll use in the next segment for setting up our fixture offset, and load this into the spindle. Now note, when loading tools for the Fadal 4525, you're always going to be loading them directly into the spindle and then letting the machine cycle them into the tool changer. We're never going to be loading tools either into the tool changer arm or the tool changer directly. Everything is going to be going into the spindle and then let the machine load it up. Okay, so same process. I got my hand in the safe zone, and I can, even in MDI mode, load a tool directly just by hitting tool in and out. Release it, and now our edge finder is loaded as tool 3 into the spindle. And we can exit out of that. And then we'd be ready to go into a fixture offset setting at this point.